Welcome D-Lab everybody, and happy weekend. In the shop today I have a pretty unique piece. This is an early 50s Fender Pro amplifier. I've never had one of these in the shop, so it's kind of a treat to work on. The issue is it's got noise, lots of noise. So the owner has already had this in a couple different shops for evaluation, and every time he gets it back still has noise. So this amp runs 3 6SC7s. They're a metal tube and they're famous for being microphonic. The output tubes are a pair of 6L6s. Rectifier tube is a 5U4. So you can hear she's already got some little static pops going on. Let's just tap the tubes for the heck of it. I'll start with the rectifier. Nothing there. Here's the 6L6s. Not too bad. Here is the first 6SC7. And you see he's pretty much, whoa, listen to that one. So this one in the center, very sensitive, which could be making them all sound microphonic. Okay? There is some static crashes. It's going to be a fun one. So I've got my suspicions already of what's going on. Obviously we have some microphonic tubes, but this is also loaded with the old original resistors. The plate resistors are so old they don't even have a tolerance band on them. Okay? So as you guys know, older carbon resistors, when they break down, can start having a little arky sparky going on inside. Could be generating those little lightning crashes that we're hearing, like that one. So let's go over the amp. I'll show you how she was made. This thing's so early that it didn't have the typical Fender transformers. These were made by Triad Electronics out of California. How cool is that? So let's look it over and I'll point out the things that I'm going to try to change out first, and we'll see what that does to the noise level. Alright, let's start by sweeping the front panel. You can see that Fender Pro amp logo. This is kind of built like the early Bassman amps, same type of chassis. There's my evaluation glass of wine. There's the output transformer. And there's that big old Triad power transformer made in Los Angeles, California. Alright, very cool. Here is the bag of parts that he sent me that have been changed in the past. So it has been recapped, which is a good thing. I'm going to pause this real quick and flip the thing around. Hold on. Alright, here we are backside. You can see our 3 6SC7 tubes. So you got 2 preamp tubes and your inverter. A pair of 5881s, which are 6L6s. They look like they've been running pretty toasty. And an old RCA 5U4. Alright, let's take a look bottom side. Alright, let's start over here in the power supply section. First off, somebody updated this with a grounded power cord. New fuse holder appears to be installed. The old filter caps have been changed with a set of F&Ts, and the dropping resistors in between are also new. There's a new little electrolytic there. Got some Jupiter caps. These would be the grid coupling to the 6L6 output tubes. And if you look over here, you'll see they kept the old Astron tone caps, obviously to keep that mojo alive in the amplifier. But the thing that I spotted right off the bat are these old resistors that don't have any tolerance bands. So these 250K resistors, those feed the plates of the 6SC7 preamp tubes. Okay, and if you look, you'll see some of them are a little bit darker than others, meaning they're heating, meaning there could be some internal arcing. So if you envision the older Fender amps, they had 100K resistors that went to the 12AX7s, and when those carbon resistors start breaking down, they are a source of noise. So I suspect that's what we have going on. So the initial game plan, I'm going to change out these plate resistors. We're going to locate the microphonic tubes, change those out. We'll check the bias to the output tubes, and we'll also see if these guys are cooked, because they look like they're pretty hot. Then we'll retest and see what happens to our noise level. Alright, for the fun of it, before I just start swapping out these resistors, let's see how these 250K resistors test. Alright, so these two are tied together top side. So there's one, 326K. Here's the other, 320K. Go over here and check this one. Look at there, he's closer, but still, all these resistors are high in value. This guy here also looks like he's pretty baked. So I'm going to change the plate resistors first, verify the others, and we'll go from there. Alright, I replaced all those old original 20% no tolerance resistors. So she has all fresh carbon film resistors installed now. Also, I found one nice RCA 6SC7 tube, and these are pretty hard to get, guys. They're actually a high mu tube that was used quite often in these older Fender and Gibson amps. And so if you look these up online, they're commanding quite the price. The output tubes, as I suspected, were pretty weak, and they were a bit microphonic. So luckily, the owner had supplied a set of Sobtechs that he got in the past. Good thing he got them in the past, especially with what's going on in the world, which is really going to drive the cost of tube amp repair, guys. So if you have a classic amp, I would suggest you get online right now and buy yourself some spares, because there's a good chance you're not going to be able to get the Russian tubes in the future, and they are by far the best ones made. Alright, so the next step, before I get too crazy here, I need to check the idle current through these output tubes. I suspect they're running way too hot because it has that 250 ohm bias resistor, and back in the day the line voltage was lower. It's higher now, so it's going to push more current through the tubes. So let's check that first, and if I need to change the resistor, I will. Alright, I'm measuring the voltage across the 250 ohm resistor, which is biasing the output tubes. You'll see we're at around 28.5 volts. So if we take our calculator and we say 28.5 volts divided by the 250 ohm bias resistor, that's 114 milliamps of current. So you divide that by 2, that's 57 mils going through each of those 6L6s, assuming they're balanced. Either way, that's excessive. I can feel the heat coming off of these tubes. They're running way too hot. So we are going to change the bias resistor and bring that current down to about 30 mils per tube. Alright, I've jumped in a new bias resistor. Right now I have three 1.8K resistors in parallel to give me approximately 600 ohms. You can see my direct current going through the resistor, which is 64 milliamps. So if we take 64 divided by 2, we're about 32 milliamps per tube, which is plenty acceptable. So now I'm going to go ahead and get these resistors installed, and we'll put a signal through the amp, see how that noise level is doing. Alright, I believe I've solved all the major noise issues with this Fender amplifier. Main violators in the preamp were these Kenrad 6SC7s. As you heard in the beginning of the video, they were very sensitive. You just touch them and it was like bong bong bong, like an electronic drum. Okay. I've also replaced all the resistors, so those 20% resistors are history. The inputs had the 5 meg, which you can't get, so I replaced those with 4.7 meg carbon resistors. The output tubes now are a new set of Sobtechs, and they're biased properly to about 32 milliamps a piece. So the amp at this point is ready to test. Nice and quiet. Alright, now we're testing that Fender Pro. It's 1950 something, I'm not sure what the age is. But this one came in just a total noisy mess. So I believe I fixed it. there's full treble.
I don't want full
You know, what do you want? Runs those metal tubes on the inputs as 6 SC7s. Yeah. Good deal.
Came out good.
Yeah, man.
Nice sound amp.
Yeah.
That's
It's just rich. Really rich.
That's the best sound amp today.
Yeah.
That beats out the champ.